Hello, today's topic is flywheel. Flywheel is a mechanical device which is used to store energy during peak time and release it uniformly during lean time. Now, the first question which arises in the mind is, what is flywheel? Flywheel is a circular rotatory device which is embedded in a shaft. This is hub in which shaft is attached. Suppose this is the flywheel and in this direction shaft is attached to this, and along with this shaft rotation flywheel rotates. Suppose like this is flywheel and this is shaft. So like this is shaft. When this rotates, then flywheel also rotates with the same direction as the shafts, along with the shafts. Now what is the function and why we will use flywheel? The main purpose of using flywheel is to store energy in the forms of inertia. Suppose this is the flywheel. Now when we give power, then it starts rotating. Suppose I am giving power to this. Suppose and generally it is used in IC engine or in which there is not uniform power distribution, uneven or ununiform distribution of power. In 3 strokes power is consumed and only in 1 stroke power is generated in IC engine. That's why flywheel is more needed in IC engine. Suppose this is the power stroke, I give power to this and this starts rotating. Now only in power stroke it will get rotation or power, and other 3 strokes are there which consume power. That's why flywheel is necessary to store the energy in forms of inertia and releases it in lean time, that is in other strokes. That's why flywheel is used. So from the definition, it is a device which is used to store energy during peak time and releases it during lean time, and lean time uniformly. Now flywheel can be of any shape, but generally this is the common shape of flywheel in which hub is there, and in this hub shaft is attached in this way. And now it is rim. These are the arms. So this is the general construction of flywheel. Now flywheel is used in IC engine, most importantly IC engine. IC इंजन में जब हम फ्लाईव्हील यूज करते हैं तो क्यों करते हैं, इसको हम लोग देखते हैं टर्निंग मोमेंट डायग्राम्स. बिकॉज टर्निंग मोमेंट डायग्राम इज वेरी इंपॉर्टेंट, बिकॉज IC engine gives power to the crankshaft and crankshaft start rotating or gets movement, turning movement, or flywheel is attached to the crankshaft. So that's why the turning moment diagram is very important to understand the working of flywheel. Suppose this is the turning moment diagram or the flywheel in which this is the suction stroke from here to here. This is the suction stroke, first stroke in which the fuel or the air fuel mixtures get into the cylinder. This is the compression stroke in which a piston compresses the fuel or the gas charge particles. Now from this to this point, this is the power stroke in which fuel got combusted and combustion of fuel gives power to the piston then transfers power to the crankshaft and so on. And now finally when combustion is over, then it's exhaust stroke in which the burnt fuel is out from the chamber or cylinder chamber through exhaust port or the exhausts. Now this is the common diagram. Now while distributing this power uniformly, here is the maximum torque we are getting in power stroke only, and in other strokes these are the powers, negative power. Here negative power. That means it consumes power. In this strokes it consumes power, and only in this stroke, that is power stroke or the expansion stroke, we will get maximum power or the power This is the power area. Now by using flywheel, this extra power is given to this one. This extra power is given to compression, suction stroke, compression stroke, and exhaust stroke, and then the engine or the engine shaft is uniformly rotated, and uniformly rotation gives a mean torque. This is the mean torque. This dotted line is the mean torque that produces by the engine. Mean torque produced by engine. And if there is no flywheel, then we will get this uneven power throughout the cycle. And while using flywheel, the power will be distributed, or the energy will be distributed from very high to uniform power distribution or uniform energy distribution, that is T mean. Okay, so that's why we use flywheel in our IC engine and in press or in many other devices we use flywheel. Now what is the fluctuation of energy? The second thing is, what is the fluctuation of energy in flywheel? Now the variation of energy above and below the mean resisting torque. Yes, we already got a mean resisting torque in our previous page. This is the mean resisting torque. In this mean resisting torque we assume that the whole power, that is suction stroke, is also here. We will get power here in suction stroke also, in compression stroke also, in power stroke also, and in exhaust stroke also. The maximum power, or the T mean, that is this positive loop, it is uniformly distributed to all the other strokes. That's why it is uniformly during lean time, and lean time is, for this is the suction stroke, compression stroke, and exhaust stroke. And peak time, this is the peak time. So the energy from peak is distributed to leans, and hence uniform mean torque is developed by the flywheel. And this is the uniform mean torque in which engine starts, or engine works. Now fluctuation of energy, because when we get power, flywheel get extra energy, and that extra energy is fluctuation, because when we get energy, we are in higher state, and when we lose energy, we are in lower state. That why there is a variation in energy. The variation of energy above and below the mean resisting torque line are called fluctuations of energy. That is, this is the mean resisting torque line. This is T mean. This is T mean. But also in T mean we get a fluctuation of energy. Very small fluctuation, but there is a fluctuation of energy, because sometimes we get energy during power stroke, then in the beginning of the stroke, when we get the power, then it is in higher state, so there is fluctuation. Then when we start losing in other stroke, it will get an lower energy side. This is for higher energy side, then lower energy side, higher energy side, lower energy side, and so on. And when we complete the complete cycle, then finally we get in this position, and from A, this is A, after G we will attain A, and these cycles go on and go on and go on. Now the variation which exists during the mean resisting torque line is called fluctuation of energy. This is the fluctuation of energy, that is energy A1, A2, A3, A4, A5, and finally after G it will attain A position, that is this position. Okay, now let us assume that energy in the flywheel at A, at this point beginning, is E. Suppose the energy in flywheel is E at very beginning. Now energy at B, this point B, will be E plus A1, E plus A1 energy. Now at C, E plus A1 minus A2, E plus A1 minus A2. In D, E plus A1 minus A2 plus A3, and in this way at E, E plus A1 minus A2 plus A3 minus A4, and at F, E plus A1 minus A2 plus A3 minus A4 minus A plus A5, and at G, this point, at this point E plus A1 minus A2 plus A3 minus A4 plus A5 minus A6, and that is also equals to energy at A. Energy at A, that is our initial state. That is cycle repeats at after G. At G point cycle repeats itself and it's go and go and go and in a cyclic process it goes, the fluctuation of energy goes on, and we have to study the fluctuation. Now let us consider, after this let us consider that the greatest of this energy is at B. Now the greatest of this energy, suppose we consider it at B, this point, the energy is at maximum, that is it is very high. That means this energy is at B and least at E, and the lowest energy we will get at E, at this point, maximum at this and minimum at this. Then the maximum energy in the flywheel, would be E plus A1, and minimum energy in the flywheel, what will be the minimum energy? E plus A1 minus A2 plus A3 minus A4. Therefore maximum fluctuation of energy, then what will the maximum fluctuation? Delta E, maximum fluctuation of energy, delta E is equals to maximum energy minus minimum energy, that is E plus A1 minus E plus A1, this minus E plus A1 minus A2 plus A3 minus A4. This is the maximum, this is the minimum. When we solve it, then A2 minus A3 plus A4, this is our fluctuation of energy, that is delta E. Okay, now what is the coefficient of fluctuation of energy? This is the fluctuation of energy. Now what is the coefficient of fluctuation of energy? It is the ratio of maximum fluctuation of energy to the work done per cycle. That means this is the maximum fluctuation of energy, that is delta E divided by work done per cycle, that is CE. It is denoted as CE, coefficient of fluctuation of energy. C is maximum fluctuation of energy divided by work done per cycle. That means delta E by tau mean into theta. This is the work done per cycle, whereas work done per cycle is T mean, torque mean into theta angle. Some values of C, coefficient of fluctuation of energy, for some example are C is 0.214 for single cylinder double acting steam engine. For a double acting steam engine, the value of C would be 0.21, and for cross compound steam engine it will be 0.096, and for CE for single cylinder gas engine it will be 1.93. That means if coefficient of fluctuation of energy is high, that is C, the value of C is high, then we need flywheel, and it is very important to use flywheel. And if the coefficient of fluctuation of energy is very high or very more than, we need bigger flywheel always. And for single cylinder it is very necessary to use flywheel, and if we use multi-cylinder like 4-cylinder 6-cylinder engines, then the flywheel size of flywheel should be small, because in every stroke the cylinder, if suppose there is 4-cylinder, then there are 4 power strokes. That's why the compensation of energy is there. That's why we don't use heavy flywheel and we use lighter flywheel instead. Now the second thing is coefficient of fluctuation of speed. When we get energy, we are in higher speed side, and we lost the energy, then we are in lower energy side. The same way in flywheel also, when flywheel gets energy, that is in power stroke, then it is in higher speed, and when it start losing the energy, then it is in lower speed side. Suppose this is the power stroke, suppose this is our flywheel, this is the power stroke. When we give power, then it is in higher speed, and it's starting then the mean resisting torque is very high, and after some time when it loses energy, then its speed is very low, and after that when we get its power, then its energy is increasing in its power, or its speed also increases. That's why the difference between the maximum and the minimum speed during a cycle is called maximum fluctuation of speed. The maximum and minimum speed during a cycle is called maximum fluctuation of speed. Now, the ratio of maximum fluctuation of speed to the mean speed, the ratio of maximum fluctuation of speed, the maximum minus minimum to the mean speed is called coefficient of fluctuation of speed. This is also known as coefficient of fluctuation of speed. Same as the coefficient of fluctuation of energy. Now let us consider N1 and N2. These are the two. N1 and N2 are the maximum minimum speed in RPM. Then N is the mean speed. And N is the mean speed in RPM. Then N is equals to N1 plus N2 by 2. Okay. Now the coefficient of fluctuation of speed CS is N1 minus N2, maximum minus minimum, N1 minus N2 divided by N means mean speed is equals to 2 N1 minus N2 divided by N1 plus N2. Why? Because N is equals to N1 plus N2 by 2. If we put the value of N is equals to N1 plus N2 by 2, then we will get 2 N1 minus N2 divided by N1 plus N2. And in terms of angular speed, it will be 2 omega 1 minus omega 2 divided by omega 1 plus omega 2. In terms of linear speed, it will be 2 v1 minus v2 divided by v1 plus v2. Okay, this is our flywheel, and in next topic we will discuss about governor. Okay, thank you.